NENOMATICA, where mathematics meets YouTube excellence. Welcome. In this lesson, we will use Newton's binomial theorem to expand a plus b to the n and a minus b to the n step by step, exactly following the algorithm. The rule says a plus b to the n equals the sum from k equals 0 to n of n choose k times a to the n minus k times b to the k. Step 1. Write the expansion of a plus b to the n. The binomial expansion for a plus b to the n unfolds term by term using factorials in the denominators. Let's write it explicitly. Step 2. Write the expansion of a minus b to the n. The same coefficients appear, but the signs alternate because b is replaced by negative b. Let's write it explicitly. Great job completing the expansions. Quick challenge. Can you write the fourth term of a plus b to the n and a minus b to the n explicitly for n equals 4? Take a moment to think, then we will reveal it. Recall the general k plus 1th term for a plus b to the n is n choose k times a to the n minus k times b to the k for n equals 4 and k equals 3. That gives 4 choose 3 times a to the 1 times b to the 3, which equals 4ab cubed. For a minus b to the n, multiply by negative 1 to the k. With k equals 3, the sign is negative, so the fourth term is negative 4ab cubed. Example. Below is the problem in bold orange math. We will apply Newton's binomial theorem. It says, open quote, left parenthesis, a plus b right parenthesis to the n equals the sum from k equals 0 to n of n choose k times a to the n minus k times b to the k, close quote. Step 1. Substitute it equals 2x, b equals y, and n equals 5. Quick challenge. How many terms will there be when n equals 5? Step 2. There will be 6 terms from k equals 0 to 5. Let's list them explicitly. Step 3. Evaluate each binomial coefficient and the powers of 2x. We will simplify each line. Tip. The combinations for n equals 5 are 1, 5, 10, 10, 5, 1. Step 4. Add all simplified terms to get the final expanded polynomial. In this lesson, we will expand a plus b to the 4th power using Newton's binomial theorem. Here is the rule. Newton's binomial theorem says, open parenthesis, a plus b, close parenthesis to the power n, equals the sum from k equals 0 to n of n choose k times a to the n minus k times b to the k. First, write the general expansion pattern in term form. It begins with a to the n, then n times a to the n minus 1 times b, then n times n minus 1 over 2 factorial times a to the n minus 2 times b squared, and so on, ending with b to the n. Now substitute n equals 4. Replace n with 4 in each coefficient. Watch the factorial style coefficients appear. The same coefficients can be written using combinations. They are 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. Now, we simplify the coefficients. For n equals 4, the coefficients are 1, 4, 6, 4, 1. Let me show you where they come from using Pascal's triangle. Using those coefficients, the simplified expansion becomes a to the 4th plus 4 cubed b plus 6 a squared b squared plus 4ab cubed plus b to the 4th. Quick check. The combination values are 4 choose 0 equals 1, 4 choose 1 equals 4, 4 choose 2 equals 6, 4 choose 3 equals 4, and 4 choose 4 equals 1. Perfect. Challenge time. What about a minus b to the 4th power? The same coefficients appear, but the signs alternate because b is replaced by negative b. That gives a to the 4th minus 4 cubed b plus 6 a squared b squared minus 4ab cubed plus b to the 4th. In this lesson, we will expand a minus b to the 5th power using Newton's binomial theorem. We will walk step by step and then apply the result to 2x minus y raised to the 5th power. Here is the rule for a minus b to the n, the Newton binomial form. The signs alternate, and the coefficients are binomial coefficients. The factor, negative 1 to the k, flips the sign. The binomial coefficient, read as n choose k, gives the numbers 1, n choose 2, and so on. Then we have a to the n minus k and b to the k. Step 1. Write the binomial expansion formula for a minus b to the n. This is the expanded factorial form with alternating signs. Step 2. Substitute n equals 5 into the formula. Carefully keep the alternating signs and the factorials. Step 3. Simplify the factorial coefficients. These simplify to the binomial coefficients 1, 5, 10, 10, 5, 1. So the result becomes a to the fifth minus 5a to the fourth b plus 10a cubed b squared minus 10a squared b cubed plus 5ab to the fourth minus b to the fifth. These coefficients come from row 5 of Pascal's triangle. Now, apply the result to expand 2x minus y to the fifth power. Start by substituting at equals 2x and b equals y into the simplified expansion we just found. Then compute the powers of 2 and multiply the coefficients. Now multiply coefficients and collect like terms. We get 32x to the fifth minus 80x to the fourth y plus 80x cubed y squared minus 40x squared y cubed plus 10x y to the fourth minus y to the fifth. This is the fully expanded form. Here is the problem statement in bold orange. Expand 2a plus b, all raised to the fifth power. We will use the fundamental rule called Newton's binomial theorem. The theorem states, left parenthesis x plus y right parenthesis to the n equals the sum from k equals 0 to n of n choose k times x to the n minus k times y to the k. Step 1. Identify the parts. We set x equal to a, y equal b, and n equal 5. Substituting into the theorem gives left parenthesis 2 a plus b right parenthesis to the fifth equals the sum from k equals 0 to 5 of 5 choose k times 2a to the 5 minus k times b to the k. Quick challenge. Before we expand, can you predict the 6 terms we will get from k equals 0 to 5? Step 2. Write all 6 terms explicitly. We use the row of Pascal's triangle for n equals 5 as 1, 5, 10, 10, 5, 1. Here is that coefficient row. Now we list the 6 terms from k equals 0 to 5. Step 3. Compute the binomial coefficients and powers of 2a. We simplify each term. First term, 1 times 32a to the 5 gives 32a to the 5. Second term, 5 times 16a to the 4b gives 80a to the 4b. Third term, 10 times 8a cubed b squared gives 80a cubed b squared. Fourth term, 10 times 4 squared b cubed gives 40a squared b cubed. Fifth term, 5 times 2ab to the 4 gives 10ab to the 4. Sixth term, 1 times b to the 5 gives b to the 5. Step 4. Add the 6 simplified terms. We combine them into the final expanded form. The result is 32a to the 5 plus 80a to the 4b plus 80a cubed b squared plus 40a squared b cubed plus 10ab to the 4 plus b to the 5. We will expand the 7th power binomial exactly using Newton's binomial theorem. First, display the example and the problem statement in bold orange math. Then we recall the theorem as a rule before we start the steps. Step 1. Write the general expansion formula for the 7th power. We'll title this step. Then place the unsimplified factorial form of each coefficient. Quick challenge. Can you compute each binomial coefficient before we simplify? Step 2. Simplify each binomial coefficient. We first title the step. Then we list all 8 coefficients for k equals 0 through 7, highlighting these new values in orange to emphasize the change from the previous step. Step 3. Write the fully expanded form. We will place the step title. Then we show the complete expansion. The numeric coefficients that changed from the previous step will be shown in orange, and the final answer will be emphasized in green. Finally, we celebrate the completed expansion. Example, we will expand the product a minus b to the 8th power times a plus b to the 8th power, strictly following 4 clearly labeled steps with rule boxes. Step 1. Recognize the product structure. We first factor the middle by the conjugate product. A minus b times a plus b equals a squared minus b squared. Then we raise that to the 8th power. Step 2. Apply the binomial theorem. We substitute x equals a squared, y equals negative b squared, and n equals 8 into Newton's binomial theorem. That produces a summation from k equals 0 to 8. Step 3. Simplify each term and write out the sum explicitly. We expand term by term, keeping the binomial coefficients symbolic for now. Notice the alternating signs coming from negative b squared to the power k. Step 4. Replace the binomial coefficients with their values. Using 1, 8, 28, 56, 70, 56, 28, 8, and 1. That gives the fully expanded result. We will expand the binomial power a plus b raised to the sixth power using Newton's binomial theorem. First, we label this as an example. Then, we present the problem clearly in orange bold math. Quick challenge. Can you predict what the general expansion looks like before it appears? Rule. Reminder. We apply Newton's binomial theorem. Step 1. Write the general expansion with n equals 6. We substitute n equals 6 into the summation and write every term explicitly. Step 2. Substitute the binomial coefficients. The values are 1, 6, 15, 20, 15, 6, and 1. Step 3. Write the simplified result. We now present the clean polynomial form. Great job! This is the final expanded form. The problem is, expand the quantity 3x plus 2z, all raised to the fourth power. We will use the rule called Newton's binomial theorem. It says left parenthesis x plus y right parenthesis to the power n equals the sum from k equals 0 to n of n choose k times x to the n minus k times y to the k. Step 1. Identify x, y, and n. We choose x equals 3x, y equals 2z, and n equals 4. Substituting these into the summation form shows the structure of all terms. Step 2. List each term using the binomial coefficients. The coefficients for n equals 4 are 1, 4, 6, 4, 1. We apply the rule and substitute k from 0 to 4. Now compute each term carefully and keep all math in bold. Step 3. Sum all the terms. We add the 5 bold terms to write the final expansion. Combine them in order of descending powers of x. Then we display the result in green. Here is a small 3-dimensional style visual as a fun note representing the fourth power as a volumetric growth idea. In this lesson, we will expand the expression open parenthesis 2i minus 1 close parenthesis to the sixth power using Newton's binomial theorem. Let's write the problem first, and our goal is to expand it into a standard polynomial in I. We will use Newton's binomial theorem for a minus b to the n. It says open parenthesis a minus b, close parenthesis, to the n equals the sum from k equals 0 to n of the binomial coefficient n choose k, times a to the n minus k, times negative b to the k. For our expression, 2i minus 1. The a is 2i, the b is 1, and n is 6. So we get the sum from k equals 0 to 6 of 6 choose k, times 2i to the 6 minus k, times negative 1 to the k. The coefficients, 6 choose k, come from Pascal's triangle row 6. Those are 1, 6, 15, 20, 15, 6, and 1. The factor negative 1 to the k alternates the signs, plus, minus, and so on. Now we compute each term. For each k, take the binomial coefficient, the power of 2i, and the sign from negative 1 to the k. We will simplify and collect the powers of I. K equals 0. 6 choose 0 times 2i to the 6 times negative 1 to the 0 equals 64i to the 6. K equals 1. 6 choose 1 times 2i to the 5 times negative 1 to the 1 equals negative 192 I to the 5. K equals 2. 6 choose 2 times 2i to the 4 times negative 1 to the 2 equals 240 I to the 4. K equals 3. 6 choose 3 times 2i to the 3 times negative 1 to the 3 equals negative 160 I to the 3. K equals 4. 6 choose 4 times 2i to the 2 times negative 1 to the 4 equals 60 I squared. K equals 5. 6 choose 5 times 2i to the 1 times negative 1 to the 5 equals negative 12i. K equals 6. 6 choose 6 times 2i to the 0 times negative 1 to the 6 equals 1. Finally, we add all 7 terms together from k equals 0 to 6. The expanded form is 64a to the 6 minus 192a to the 5 plus 240a to the 4 minus 160a cubed plus 60a squared minus 12a plus 1. This is the expansion of open parenthesis 2i minus 1 close parenthesis to the 6th power. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.